So e raised to 1/2 equals x. Perfect. So I have to put 1.6 in the table. Here's 1.6. This is 0.5. 1.6 is right somewhere between 0.5 and 4. I put a 0 here. I go back, I put the function in the graphing calculator and determine the y value for 1/2, the y value for 1.6, and the y value for 4. These are crucial values. I have to determine them. So in y equals, I put this new function in, which is x to -2, or I can just write natural log x, and I divide the whole thing by x squared. It doesn't matter how you want to plug it in, as x to -2 times natural log or natural log over x squared. And I have to plug in 3 values, just these 3. I don't care for anything else. 0.5, 1.6, and 4. That's it. So we have -2.8, 0.2, and 0.1. Okay, fine. Perfect. So now I have to study the sign of the derivative. Now, on the interval 1/2, 4, what type of sign does x cubed have? On the interval 1/2, 4, what is the sign of the denominator? On the interval 0.5 to 4.
Positive?
Always. Perfect. So now, all I have to do is, in the derivative, plug in a number to the left of 1.6. Like, for example, 1. If I plug in 1, how much is natural log 1? And we know that. Natural log 1 is natural log 1
0.
Yes. So if this is 0, 0 plus 1 is positive. Now I'm going to plug in 4. I don't know what that is, but I have my calculator quickly before, instead of switching. Here it is, -2 times natural log 4 plus 1. Negative. That's all I care about. I don't care for the number. I only needed the sign. At this point, if these 2 rows do not work well together, then I'll say, oops. So, from -2.8 to 0.2, what does the function do?
Increase?
Yes. Is that supported by the sign of the derivative?
Yes.
From 0.2 to 0.1, what does the function do?
Decrease.
Yes. Is that supported by the sign of the derivative?
Yeah.
Yes. What type of point will be? Don't say anything, so let's picture it. So this is -2.8, and it goes up to 0.2 and then down to 0.1. So from left to right, what type of point is 1/2, -2.8? This one.
An absolute min?
Excellent. Is it a relative?
No, because we don't know what's on the other side.
Because it's at the end point of the interval. Awesome. 1.6, 0.2. This one. What type of point is that?
Absolute and relative max?
Yes. Absolute and relative max. Awesome. Finally, what type of point is this?
Absolute min, but not relative. Or no, it's nothing because it's not low.
Exactly. So it cannot be absolute max or min because there is another higher and another
Okay.
lower. And it cannot be relative because it's at the end point of the interval. Awesome. How do we feel so far? Is this okay?
Mm-hmm.
Okay, perfect. So I think we can move on now. Okay. Let me see where I'm with this video. Okay, just started. Very good. So at this point, I'd like us to move on. And I'd like to look at a word problem before we continue, though. So here it is. Either the antibiotic or the volume or the weight, whatever. Volume. Okay, so 75. Between 0 and 30, okay. Degrees Celsius, okay. The volume in cubic centimeters, okay. Good. Of 1 kilogram of water at a temperature T, okay, so T is temperature, is given approximately by the formula. Fine. So V equals 999.87 minus 0.06426 T plus 0.008504 T squared and minus 0.0000679 T to the third. And after this, we will have to ban Amanda from choosing. I'm absolutely kidding. Good. So we have the function. Find the temperature.
I don't know, I might ban myself looking at these.
That's
numbers.
okay. That's a good one. Find the temperature, because this is what real life is all about. Find the
How many
temperature.
zeros are in that last term?
I think 4.
Is it?
I think 4. 0.40679 T cubed.
Okay.
Find the temperature at which water has its maximum density.
Is there, sorry, side note, is there a reason that they don't put these polynomial functions in standard form?
Just to throw us off, I think.
That's what I wasn't sure if it was only because we were supposed to know to put it like that it's not in standard form, or if there's some reason that people actually do that in the real world.
No, they like to do that. So find the temperature at which water has its maximum density. They're not talking about volume. They're not talking about temperature. They are throwing at us density. Okay, so let's remember what density is all about. So the notation for density is this: rho. Anyone remembers what density equals to?
I'm assuming it has something to do with space and occupancy, but I have no idea what the formula is.
So let's think for a moment. Let's look it up. Very easy to look it up, and you'll see what you get. The formula for density.
Mass divided by volume.
Yes. I truly believe that they probably have a typo in here.
Oh, because it's talking about temperature.
No, actually, they're giving us 1 kilogram. I forgot about that. I skipped that.
I think maybe we just go with a different number.
Oh, no. So what I'm saying is they are giving us the mass. The mass is 1 kilogram. We're gonna look at it just one more time. Let's take a look. I'm just, where's my, where are you guys? Okay. So of 1 kilogram of water, so we do have the mass. So there is no problem to create a function for rho, for the density. So let's do that. So in our case, let me stop sharing. So in our case, rho equals 1 divided by the volume, because the mass is given to us as 1 kilogram. So basically, this is the volume raised to -1. Not a big deal. So first of all, we have to differentiate rho of t. And we have all this function raised to -1. So we bring down -1. Yeah, with this is very clear now. I just skipped that and I said, oh, no, wait a minute. So -1, all that volume to -2 times the inner function prime. This prime is 0. This prime is -0.06426. This prime is positive. I have to multiply this by 2. So it's 6 and it's 8 and it's 0 and it's 1, 16, 17 and it's 0.0 t. And the last one, minus 7 and 2, 21, 23 and 2, 20. And now let's see how many zeros. 3 zeros. So 1.
Is that a 7 at the end of that?
It's a t.
Squared term?
It's a no, it's a t. So sorry, yes, it's this t. So I'm checking, so this is t squared. So I'm checking again. Very good problem. Very good problem. You always choose the best. So that prime is 0. This prime is that. I have it correct, yes. Then times 2, I have 6. I have 8. I have 0. 1.
I'm getting something else in the calculator.
Yes, I have an error. I just realized.
Yeah, that second one should be a 0.
6, 8, 0. Yes, this is a 0. And carry 1, 16, 17. Yes, that's correct. That's correct now. I'm checking the last number. 7 and 2, 21, 23, and 2, 18, and 20, and 3 zeros. 1, 2, 3. Okay, perfect. And now we have to set this equal to 0 and see what happens. So I'm going to plug this in that in the poly feature. Okay, number 9. But we have to be very careful how we plug it in, because as Amanda noticed, oh, first of all, it's degree 2, so I have to go back. So that's correct, but it's degree 2. Degree 2, enter. Okay, so as Amanda noticed, we have to be very careful how we enter it. They have to be in the correct order. So this is the negative point 3 zeros, 2037, and that's okay. The next one is the 0.0170086. And the last one is that negative 0.06426. Good. Not a big deal. No problem there. Okay. So we get, and that was t. T equals 3.967, and t can be 79.53. Okay, that's not sufficient. These numbers mean nothing if we don't study the sign of the derivative. We don't know what they mean. And again, the question was, let me share again. The question was, find the temperature at which water has its maximum density. So we're looking for the maximum point. I don't know which one gives the maximum. I have no clue. So then I have T in between 0 and, that was between 0 and 30. One more time. Between 0 and 30. T is given approximately, so then T is, okay, so 79.53 is not even in the interval. So 3.967. So this is rho prime of T. And this is rho of T. Good. So I have 0 here. If this is a maximum, then you know what the signs should be. But I don't know. I can't figure it out. I mean, I cannot just say, oh, it's potentially positive and negative. No. I have to make sure that that's correct. So this is going to be always positive because it's 1 over v squared. So this quantity doesn't mean anything. Now the negative 1, so when I plug in 0 here, this is 0, this is 0, this is negative, but with negative, that's exactly what I was hoping. So now, if I plug in, so the other solution is right here. So this piece has to be negative. How do I know? Well, I can plug in 10. It's between 3.9 and 30, or basically between 3.9 and 79. So when I plug in 10, since the leading coefficient is negative, but multiplied by a negative number, so I know that the function opens up, and it crosses the x-axis at 3.9 and 79. So this piece has to be negative. So this is the correct answer, and the only answer. And this will give a maximum density. This in degrees Celsius will give the maximum density for a mass of 1 kilogram of water. Very good pick. It was a very interesting problem.
Mm-hmm.
Thank you for picking that. Awesome.
Okay.
Good. So we are continuing. I would like to, let me change the